Hi guys, and welcome to a new video. So in this video we want to show the following: that the integer part of 2 times the square root of n squared plus n plus 1 is equal to 2n plus 1, where n is a natural number not equal to 0. Okay, but before we get on with the proof, a reminder only of what the integer part of a real number is. So the integer part of a real number x, which we usually denote by this expression, that is x between square brackets, is the greatest integer less than or equal to x. So in mathematical terms, the integer part of x is the maximum over the set of integers, so the maximum of all p belonging to z, such that p is less than or equal to x. Or, in more precise mathematical terms, the integer part of x is equal to p if and only if x lies in this interval. And we can see here that we have an equality sign on the left hand side here, but no equality sign on the right hand side here. And this is how it should be, because suppose that we had an equality sign here as well, then p would no longer be the greatest integer, but p plus 1. So this is why we don't have an equality sign here. Okay, so let's get to the proof here. So let n belong to n star, that is the set of all natural number without 0, then n squared plus n plus 1/4 is strictly less than n squared plus n plus 1. And this is no strange, because n squared plus n is the same here, and 1/4 is strictly less than 1. And this in its turn is strictly less than n squared plus 2n plus 1. And once again, the right hand side here is n squared plus n plus 1, which is the same here, plus n, which is greater or equal than 1. So we have this double inequality. Now now the left hand side here is n plus half to the square, and the right hand side is n plus 1 square. And taking the square roots of the whole inequality, we get n plus half less than or strictly less than the square root of n squared plus n plus 1 less than n plus 1. And now multiplying by 2, we get 2n plus 1 strictly less than 2 times the square root of n squared plus n plus 1 strictly less than 2n plus 2. And according to the definition of the greatest of the integer part, we can conclude that the integer part of this number is nothing but 2n plus 1, which is an odd natural number, that is, it belongs to this set. So that's it, guys, for this time, and thanks for watching, and see you on the next video.